Hello, welcome to today's webinar, Technical Debt is Good. We're very excited to have Steve Green presenting today. He's new to Oakwood, but definitely not new to this industry or this topic. In fact, today's webinar is almost a sneak peek to some future speaking engagements Steve has coming up on Technical Debt is Good. He's speaking at the VML Speaker Series on August 20th in Kansas City, as well as the App Dev Trends in Las Vegas, December 8th through the 11th. So we're very excited to bring you an abbreviated version of Technical Debt is Good. For more information on those events, you can visit the Oakwood website for additional information. As a reminder, there will be a Q&A session at the end of the webinar. However, feel free to ask any questions as we go along via your chat pane, and Steve will address those at the end of the webinar. And lastly, this webinar will be recorded. You will receive an email with a link to that webinar within 24 hours or so. Without further ado, I hand it over to Steve Green.
Everyday lives and how that applies to what we see in our technology lives as well. Secondly, we're going to learn some mechanisms to identify debt. This is both identification and to qualify what good debt looks like and what bad debt looks like. Third, we're going to develop some strategies to manage that debt. Whether that's within our project teams or as business stakeholders. We're going to learn a little bit about what are the mechanisms that I can put in place in order to maximize good debt and minimize bad debt. Fourth, we're going to evaluate how we actually pay debt down. So once we've incurred the debt, whether good or bad, we have to have a good strategy to make sure that we're paying on that debt. And we're going to look at some mechanisms that ensure that we're doing that appropriately. Lastly, we're going to discuss some strategies around utilizing debt. What are some of the mechanisms I can use to put good debt in place to make sure that I'm maximizing business value? So without further ado, we'll start with the first one. What is technical debt? Now, my guess is that there are some folks who may have heard technical debt in the world and had a conception in their mind about what technical debt was, but maybe not a real crystal clear understanding of the definition or the historical premises around technical debt. So we're going to start at the beginning, and forgive me for a little bit of a quick history lesson, but I think it's important to understand that technical debt's actually been around for a really long time. It was actually coined in 1992 by a gentleman named Ward Cunningham, who was really one of the early pioneers in some of the early object-oriented programming techniques and agile methodologies that we really see today. And in a speech, he actually said this, and I like to read it a little bit because I think it's pretty impactful to understand how this idea came about. But he said, shipping first-time code is like going into debt. A little debt speeds development so long as it's paid back promptly with a rewrite. The danger occurs when the debt is not repaid. Every minute spent on not quite right code counts as interest on that debt. Now, in this 4 sentences, Ward did something pretty amazing in our industry. He took something that really was bottled in the technology teams and brought it to a level that allowed everybody to really understand the decisions that were happening in those teams. You know, when we were making decisions that were incurring debt that we knew were going to cause us to have to refactor or to pay out additional interest later. What's important about this is that he identified that there is, in fact, a gap. There's a gap between what happens in the business world and what happens in technology. And sometimes that gap is really difficult to communicate. It's difficult because, for the most part, technologists don't speak the same language as the business. So if we take a look at that, we understand that the perspective, when we talk about technology decisions, really matters. When we talk about the business, they see things in variations of gray, right? They live in an infinite world of compromise. They want to make sure that they're maximizing value with the minimal amount of cost. They look at flexibility, they look at change management, and they're highly tolerant to those types of environments. But when we look at technology, and specifically developers are very binary. They think in terms of on or off, right or wrong, 1 or 0. And to a developer, technical debt is something that's truly annoying. It's wrong or it's right. There is no middle ground. But what technical debt does is, as a metaphor, it allows us to connect these two conversations that are already going on and allow people to have more collaborative discourse. If I understand technical debt and the impacts of technical debt, then that allows me to contribute to the technology discussion in a way I'm not able to do normally. So that perspective, really coming out of this idea of what Ward was talking about, sets a really important foundation for collaboration. So if we look at a more formal definition then, we see that Ward said technical debt is an incomplete, immature, or inadequate artifact in the software development lifecycle. I like to simplify that. Instead, let's think about it in terms of stuff we know is wrong with the application, even though it will meet functional requirements. Now that's important. It'll meet functional requirements. This is also what makes technical debt a little bit dangerous. If I'm meeting functional requirements, it's not as visible to the business. So if I'm talking about software design or a bug that maybe isn't a functional impact, but I know that it could be better, that's a really hard sell to make to the business because the business fundamentally just cares, does it work? So if I think about technical debt like this conversation becomes even more important, not just from the business perspective, but also from the technology perspective. We as developers want to make sure that we're producing the best possible solution for our stakeholders. And if we don't have a good mechanism to communicate whether a solution is either good or bad, then that puts us in a situation where we are unable to truly communicate what we want to achieve. So we look at that a little bit more and we think about just the importance of a metaphor in general. And metaphors are critical because we as human beings actually reason by analogy. We use analogies all the time to try to discuss whether or not, some complex idea can be shared with somebody who maybe doesn't have as deep as understanding. And I've got a couple here up on the screen that gives you kind of an idea of, we see these every day, right? Put pressure on our design, can't keep running at this pace, building on a weak foundation. These ideas are ways that we're trying to communicate with non-technical people by analogy so that we don't have to explain the technical details, but they can get an understanding of the challenges that we're facing. So if we look at the power of the metaphor, what we understand is that what we're really trying to do is give us a way to explain the decisions that we are already making. Now that's important. The reality is, whether we understand technical debt or not, we're all making these decisions every single day. Designers, coders, PMs, business analysts, we're all making decisions that are affecting the overall quality of the solution. So if we understand a mechanism that allows everybody to talk about it in the same terms, then we can promote a better collaboration on those decisions and really make sure that we are all in agreement of where we want to go with the discussion. So technical debt is good. I'm guessing that in some minds that idea catches people a little off guard. But the reality is technical debt can be really good. 3 really good ways of thinking about technical debt as a positive are up on the screen. It can decrease our time to market. There are a lot of times we have projects that are time sensitive. If we're not getting to market as fast as possible, then the value of the application goes down dramatically. In those instances, technical debt can be a real positive to the overall application. I know that sounds strange, but the reality is that happens a lot. If we're building a marketing website, for say, and we know that we have a 3-month life cycle on the site, then a lot of technical debt is really not a big deal because the site will go away after 3 months. Those types of decisions become really important. But if we look at it just in a binary focus of either right or wrong or good or bad, we're not really understanding the real business impact of that decision. Secondly, we can preserve operating capital, right? If we are allowed to take on more technical debt, then we can actually reduce the cost of the overall development. And if from a business perspective that makes sense, then we can gain a lot of get a lot of features and functionalities out at a lower cost. Lastly, we can delay development expenses. If we know that we've got a long application lifecycle ahead of us, but we need to get out quickly, we can actually delay the expense of that initial build with the understanding that we're going to have to pay that back at some later point. So these are all business decisions that allow us to understand what's happening inside of the technology community. If we have a build team that understands and has this discourse with our business, then the business can strategize the best way to solve the problem. And that's important. It shouldn't be just the development team and their responsibility making those decisions. So technical debt is good because it provides that framework. Now let me also say that technical debt is not an excuse. I like to read this verbatim because I think it's important, but he said, Ward Cunningham said, the ability to pay back debt depends upon your writing code that is clean enough to be able to refactor as you come to understand your problem. Now that's important. If we don't write and take good care of our code even as we're incurring debt, then we're not actually getting good technical debt, right? What we're getting is a hot mess. We're getting code that's hard to work with, hard to maintain, hard to understand. So the premise here is that technical debt as a metaphor is good, and even as an artifact can be good, but the prerequisite for that is that we have to have code that is clean and can be refactored. If we're not hitting that standard, then we don't have good technical debt. Just like to hit it home one more time, clean enough to be able to refactor. I want you to consider this messy kitchen for a second and understand the importance of this idea of refactoring. So if we take a look at this kitchen, we notice a couple of things. One, it's a big mess. There's no time taken to clean up after someone finished a task. Day by day, no thought was given to organization. Trash isn't thrown away. In fact, in a condition like this kitchen, it is very difficult to do even very simple activities. Think about trying to bake a cake in a kitchen like this. It would quickly become a daunting task and almost impossible. The reality is, if we're not maintaining good, clean code standards, then we don't have technical debt. We have a giant mess. And the reality is, there's code bases that often to developers look a lot like this kitchen. That's not technical debt. That's a rewrite. We have to go completely bankrupt if we have a situation like this. I like this example though because it kind of helps visualize what occurs in a very abstract environment. A lot of times business stakeholders may hear spaghetti code, it's really hard to maintain, but they don't have really a clear mental picture of what that means to the dev. Sometimes painting this picture for our business stakeholders becomes really important in helping them understand the magnitude of the problem. How difficult it truly would be to bake a cake in the middle of that mess. So now we're going to move on to the second section. How do we identify debt? So we've talked a little bit about what debt is, some historical background on debt, and a little bit of an idea about the importance of making sure that we have clean code in order to have good technical debt. But it's still important to understand what happens in our normal or existing code bases and understanding how do I know if technical debt already exists. So the first thing I like to do is understand when technical debt occurs. So I want you to take a look at this graph. And on two axes, we have time and we have scope. Scope being our project, time being how long is it going to take to deliver it. We go to our development team and we ask them to give us an estimate. For a certain amount of scope, how much time is it going to take? They come back with an estimate and we plan our velocity. We say, okay, given that amount of scope, we expect it to take this amount of time. Now invariably, the development team starts working. And over a course of period of time, the line starts to flatten out a little bit. And we start measuring that and we understand that, well, actual velocity shows that if we keep this pace, we're not going to hit our timeline, right? We're going to go too far to the right. That's a problem, right? We had a timeline, we committed to it, we have business stakeholders who expect us to hit the timeline. So the business comes in and applies pressure to the development team. They say, we have to hit the timeline. Do whatever we need to do, but we're hitting the timeline. Whatever occurs then in that triangle between the planned release and what would have been a full quality release becomes the area of technical debt. Understanding when that happens helps us in understanding how to identify debt, because when I understand when debt is more likely to occur, I can be more thoughtful in terms of trying to track it. The second thing I like to say is that technical debt sometimes is just natural. Software over time will begin to rust. A good identification or identity metric for when we have technical debt can also be How old are the libraries that we're trying to incorporate into our project? If we have a lot of old, antiquated libraries, then the reality is we probably have some rusty software. And as software rusts, it naturally incurs technical debt. Some other indicators to when technical debt may occur. First, velocity. If we see a large decrease in the velocity of our team, in other words, how much code the developers are able to complete per sprint, if this happens consistently over time, then what this probably means is that the developers are having a harder time working with the code, and there's probably some technical debt that exists that they're having to deal with. So if we see consistent decreases in velocity, then that is probably a really good indication that we want to look and see if we have technical debt causing that. Next, bugs. The number of bugs per release increases rapidly. If the number of bugs are increasing per release rapidly, then that's a pretty good indicator that some technical debt exists. And if they're consistent bugs that we can't quite solve, then that probably means that we have a persistent technical debt problem. That could be a design problem, that could be a coding problem, but we probably know that there's some artifact in the software that's causing these high number of bugs. Lastly, stress. Development teams that get really stressed out are probably dealing with technical debt. Now that technical debt could be existing or incurred technical debt at the time, but when we start seeing development teams get overworked and highly irritated, normally they're dealing with a problem in the code that should be simple. It's overly complex when it shouldn't be. So if we're seeing that on a consistent basis, then it's a good time to step back and assess whether or not we have technical debt that we need to solve for. Lastly, production. If we have ongoing and unresolved issues, even after multiple release fixes, then we probably have technical debt. This is very similar to the bug issue. So understanding kind of what happens in the dev team and understanding to look at these indicators to understand if we have technical debt can really be powerful tools in understanding when we need to step back and assess what is in our code bases and when we need to potentially look at paying some of that debt down. Also, I like to just give some help in terms of training, what I like to call training our spidey sense. Things that we might see or hear in the development team that are also good indicators that some debt's about to come or does already exist. First, don't worry about the documentation for now. Technical debt can easily be things that just aren't well documented, and that over time those undocumented features of functionality quickly fester into technical debt. The only one who can change this code is Bob. If we have a specialized resource and he's the only one who can make a modification, that probably means we have technical debt. There's something in the code there that's unique that nobody else understands but Bob. That's something that needs to be refactored. It's okay for now, but we'll refactor it later. Now this is a good sign of technical debt. We know that there's a problem, but we also know that we're going to refactor it later. That's okay, but it's still a sign that technical debt exists. If we start looking at the code and we see a lot of to-dos or fix me's, this should be fixed before production. This is generally a really good assessment of technical debt and probably one of the more common ones. If I'm going through a code review and I see a lot of to-do statements, then I'm asking some questions, what's our plan to pay back this technical debt? Does anybody know where we store the database password? That happens all the time. Unfortunately, it's also a good indication that we probably have some technical debt. There's probably either not good documentation or a good design pattern being utilized that makes it very clear to the developer where we're storing passwords. I know if I touch that code, everything else breaks. This generally happens in legacy systems, but happens pretty regularly. We know that the code works right now and we're scared to touch it. Maybe because we don't understand it or maybe because it's a big mess. That's a good indication to maybe take a look and say, hey, is there some technical debt here that we can get some value back by refactoring? Let's finish the testing in the next release. If we're not adequately testing our software, then it's a really good indication that we're incurring debt. Tests are vital to understand the quality of our software, and if we don't understand the quality of our software before release, then there's a really good indicator that technical debt's going to exist. The client doesn't care, just get it done. This happens also very frequently. It's normally a sign that business pressure is being applied and that technical debt's about to occur. So if we take a look at kind of these quick statements, what we understand both as developers, developer managers, and business stakeholders is that there's discourse that happens inside of the dev team that gives us a sense that technical debt's about to occur. Now, we need to take an approach to that to say, hey, maybe I need to get involved and understand what that debt is in order to make sure that we're getting adequate business value for that debt. But what's important right now in this part is to understand that we're training the spidey sense, right? That we understand that something doesn't feel right. Additionally, we can use some automated tools to help discover when technical debt exists. The first is code coverage. What I mean by code coverage is, what is the code coverage of our testing? If we don't have automated tests that have at least 75% code coverage, then that's a pretty good smell that technical debt may exist. So as we're building our software, it's really important to make sure that we're setting an expectation with our teams of what we expect from our unit tests. How much code coverage do we expect? And that we're running those tests repeatedly. If we're not, it's a high indication that technical debt exists. I like this one just because it's a fun word to say, cyclomatic complexity. Developers can use this tool to understand the complexity of their code. Cyclomatic complexity gives us an understanding of how many logical branches exist in our code. The interesting thing is, the more logical branches we have in our code, the more complex our code becomes. Really complex code is really prone to technical debt. The more complex it gets, generally, the higher risk I have of bugs. So if I'm looking at cyclomatic complexity and I'm seeing a really high number, meaning a really complicated code base, then there's a really good indicator that technical debt may exist. Oh, sorry. Lastly, coupling. Coupling measures how interconnected our systems are. The more highly coupled our system becomes, the more interconnected it is, there's a higher risk of technical debt. As we build those tight connections, it's harder for us to maintain flexibility, and what happens over time is people start hacking in solutions to make it work. Each of those hacks becomes a piece of technical debt that I have to deal with. High coupling also produces inflexibility, solutions that become very difficult to change. As my solution becomes harder to change, it's a really good indicator that I have technical debt. So kind of understanding a little bit about how we can identify debt, both just in a general sense and then utilizing some tool bases to do that, it becomes really important to understand, how do I know whether this is good debt or bad debt? So Martin Fowler gave us a really interesting metric to do that. He gave us two axes. He said, on one side, let's pretend we have deliberate and inadvertent. And on the other, let's say we have reckless and prudent. Now this quadrant gives me a way to metric whether debt is either good or not so good. So in the first quadrant, we have deliberate and reckless. Something that may happen here is someone says, hey, we don't have time for design. We just have to start building. Well, that's reckless because without design, we have a high probability of incurring debt. But it's also deliberate. They know that they're foregoing it and moving on. Deliberate and reckless is probably the worst type of technical debt to have. In the next quadrant, we have reckless and inadvertent. Here, we have maybe a piece of technical debt that exists that nobody understood was actually technical debt. A good example is maybe a developer who doesn't understand a modern pattern of practice like dependency injection. They didn't know it existed, so they built a solution that didn't utilize it. Well, that's reckless still because we're not maximizing the patterns and practices that we should be, but it's inadvertent. He didn't know, so he built the solution anyway. Deliberate and prudent. We're just going to have to launch and make a plan. This is the best kind of technical debt because we're being both deliberate, but we're also being prudent. We know that we're incurring some debt, but we're going to make a plan later to deal with that debt. We're not going to just ignore it and move on. Lastly, prudent and inadvertent. I didn't know there was a better way to do it. This is fairly related to the reckless and inadvertent, but it's a little different in that it really kind of stems more from there's not necessarily a bad pattern in practice being built inside of the code, but instead there's maybe an older pattern or practice that's being utilized, and there's just not enough knowledge yet about maybe some modern approaches to take. This is natural. This quadrant will naturally happen over time as technology matures and changes. Maybe today we're doing the best thing, but if we were to apply the solution 3 years from now, it wouldn't necessarily be the best thing. It's prudent because I'm still trying to provide a decent solution, but it's inadvertent because there is a lack of knowledge. So if I look at each of these 4 quadrants, what I see is that deliberate and reckless is just plain irresponsible. Dev teams or dev members that do this are probably in line to be some of the worst members of the team. We really need to address that first and foremost. Reckless and inadvertent really is just an incompetence issue, right? We have to train, we have to educate developers so that they know the best patterns and practices to utilize. Inadvertent and prudent is a natural course. It's going to happen and it's okay. Prudent and deliberate, that's our happy path. When we assess technical debt and we see it in real life, we want it to be both prudent and deliberate. We want to make sure we have a plan and that we understand and are consciously making the decision to incur the debt. So a quick recap. When is technical debt good? I propose that these 4 bullets have to exist for technical debt to be good. Technical debt needs to be trackable, it needs to be prudent, it needs to be deliberate, and it needs to be valuable. I'm going to stop on that last one for a second because up to this point, we've kind of ignored technical debt as value. The reality is technical debt is good only because it can provide business value. An analogy that I would use is maybe what debt looks like in our real life. It's good that I can go into debt and buy a house. It is bad that I can go into debt and maximize every credit card I have. The value doesn't make sense. So as we look at technical debt and we're assessing it, it is critical to understand that we're getting value back for the debt we incur. Just like real life. If I'm not getting adequate value, then the debt is not good. In fact, it's probably toxic. Now we're going to move on to maybe some debt management strategies, looking at once we discover that we have technical debt or we're making a plan to incur technical debt, how are we going to deal with it in the project cycles that we run? So I'm going to offer you a couple of strategies. The first is use a separate debt backlog. Generally, we have a backlog of items that we're going to work as the dev team moves forward. Rather than tracking our technical debt in that backlog, it's highly valuable to create a separate list, to have a separate backlog where I'm tracking known technical debt. This way, there's high visibility with the business as to what decisions we're making and a good list that when we go back and decide to refactor, we don't have to sift through a whole bunch of new features and functionality in our existing backlog. It also creates a central place for developers to log debt tasks. It provides a clean separation between features and debt work. It makes the debt completely transparent. And comparing this to the feature backlog can provide really valuable insights. It can tell us, is the backlog becoming too aged? It can tell us, is there an overwhelming of the feature backlog? In other words, are we getting too much technical debt and not enough features in each build release? Additionally, as we create a separate debt backlog, it becomes really valuable to coordinate with the business and allocate a section of time in each sprint that we're allowed to pay down debt. If we do that, then we can maintain the debt backlog. It won't become overwhelming, and we can maintain control of our project as we move forward. Otherwise, we just continually grow the debt backlog and it becomes overwhelming over time. It's something that's really never going to be easily dealt with. So if we track it and we allocate a release ratio, then we can pay it down over time. And it's not as daunting of a task. Sometimes we incur debt and the next release should just be a completely technical release. There should be no additional features or functionality. Call this a cleanup release. This can be really, really helpful if we've spent a bunch of time implementing a bunch of new software or new functions and features that have never existed before. The reality is there's probably going to be some technical debt that exists during that process. So immediately following that release, if we do a cleanup release, then we can immediately address the technical debt and keep it from growing out of control. It's also really useful if we have a really hectic cycle. Maybe there was a really hard deadline that the dev team was asked to meet and they met the deadline, but utilizing our when technical debt occurs strategy, we expect that some debt may exist. So we give the dev team a release to address those issues. Lastly, sometimes it's really helpful for a developer just to have a buffer task. A buffer task is a task that exists that the developer can assign work items to inside of their project management solution, but assign it just as a general technical debt cleanup release. A buffer task kind of helps us understand how much time the developer is spending on that type of work. It can be really useful as we try to metric what the cost and impact of technical debt becomes over time. So giving this type of a task to a development team not only allows them the freedom to clean up code, especially small issues as they find them, but it gives us a great number of insights later onto the productivity or the impact to productivity that technical debt is having on our team. I think it's highly important that as we think about technical debt, that it's really important to tell our developers, when are you done? A lot of times developers like to say they're done, but maybe they're not exactly done. Maybe they mean, I'm done coding. Maybe they mean, I've got it to pass a smoke test. But they may not have a formal understanding of when we use the word done, what does that mean? So if I propose a definition of done for the team as almost a checklist of items to make sure that they have completed, I can minimize the impact that debt's going to have. I can make sure that we're fully tested. I can make sure that we've got business sign-off, and I can make sure that we've run all of the processes that the dev team expects. I would say that this list that I have in front of you is probably the minimum requirement for what a definition of done should look like. We should be complete, have all the development tasks been executed. Do we have unit tests? Have they been executed? Has this been reviewed by a peer? Do we have integration testing? Has the code been tested in a fully integrated environment? Do we have documentation? Has it been approved by the product owner? If we haven't done these things, then in all reality, the developer's not done, right? So it's important to just set the expectation up front with the development team that we have a definition of done and we expect these things to occur before we release code. If we do that, then there's a higher probability that we're going to minimize debt because the developer has a very clean understanding that this is the metric that they're beholden to. Developers should work as teams. This can take many different kind of variations. At the very minimum, we should be doing code reviews. A code review is an incredible tool that teams can use to not only minimize debt, but to also promote education within the development team. By educating developers as they read other developers' code, they can minimize those inadvertent types of technical debt. The other positive is it really creates a nice team collaborative environment. If we're doing code reviews and we're engaging the team in a dialogue about our code, then most generally we're more proud to talk about what we've done, and we're going to issue better code. It also helps the developers to understand that there's clear guidelines that they're going to have to follow, and that shortcuts need to be justified. And if they're not justified, then there's a problem. It's very much like the picture I have on the right of a construction company. When they build a building, they expect that it's going to have to be assessed by an outside vendor, right? That it's going to have to pass code, that the city's going to have to give them an okay that they've met certain guidelines and standards. A code review operates in a very similar way for the development team. I would say that at the very minimum after today, if you're not doing code reviews, it's the first thing that you should go back and try to implement with your teams. And also realize that code reviews don't have to be incredibly formal. I think some of the most impactful code reviews I've ever been in have been 4 or 5 devs around a table with a projector just walking through some code. It's been impactful because I get to show off what I've done, and the other developers can provide feedback all at once, and we're all getting the same information at the same time. So code reviews are an incredibly important tool that we should be using. Additionally, working in pairs can be really helpful. The reality is when we work in pairs, it acts as a real-time code review. You've got 2 brains working on a problem at the same time, and it's very unlikely that somebody in those 2 brains is going to say, oh, well, I'm going to take a shortcut here. It's much more likely that they're going to collaborate together and try to produce the best possible outcome. This helps improve the overall quality of the code and decrease the impact of technical debt. Bob Martin gave us a really important rule that I think I like to speak to help kind of minimize debt and just promote overall clean code quality. He said that the Boy Scouts have a fantastic rule. They say every time I go to the campground, I should try to leave the campground just a little bit better than I found it. Not a lot better, but just a little bit better than I found it. Well, if we take that same idea and we apply it to our projects, then what we should say is that every single time that we're in our code, we should try to leave it just a little bit better, just a little bit. If we adapt to this mentality, then it helps reduce technical debt because over time, the campground just remains clean. The project just remains clean. The impact of technical debt becomes really minimal. I love this rule, and I say it to all of my dev teams all the time. Make sure we're trying to make our solutions a little bit better every single time. Now, this is not an open case to just go ahead and rewrite the entire solution. Notice the word little. We're not making drastic changes to the software without the business buy-in, but if we can make a little improvement every single time we're in there, then that's good. That's a positive. Lastly, beware of broken windows. There was a study done in the 80s where a psychologist studying criminology went into an inner city and took 2 buildings that were right next to each other. And in the first building, they broke a couple of windows. In the second building, all the windows were intact. They waited 2 weeks and they came back. And guess what they found? The first building had been completely vandalized. More windows were broken. Graffiti was on the walls. What had happened, the second building remained completely intact, just as they had left it. There were a couple of interesting conclusions that they drew about this. The most important as it relates to technical debt and our code quality was that when somebody defiles your building, it becomes a lot easier for new people to come in and defile the building. If I have a project and I have code and I'm not treating my code with enough respect and I'm allowing broken windows just to pierce through, then the next guy that comes in is more likely to allow broken windows to exist. His own code's not going to measure up to the same quality and expectations and standards we have. So as we allow broken windows to persist, it's highly likely that they're going to grow, that we're going to get more, that the code will become vandalized. We, as developers, should have enough respect for our code that we minimize the number of broken windows we allow. If we do that, then we're only maximizing the good type of technical debt. We're not incurring those inadvertent or reckless types of debt. We're taking a proactive approach towards it. So now we're going to look a little bit about how we should pay off debt. We're going to look at a couple of strategies. I'm going to actually say that there are 3. The first is debt repayment. This is we pay all of the debt at once. We take everything that we've got, everything that we know is wrong, and we completely rewrite it at that point in time. Second, we have debt conversion. Rather than taking all of the debt and rewriting it all at once, debt conversion allows us to maybe take only pieces of the code and fix those, but other debt still exists. So we're just going to make it a little bit better, but not completely rewrite it. The last way to pay is just to pay interest only. Interest only says, hey, we're just going to let the debt exist. There's not enough business value for us to do any kind of rewrite right now, that we're just going to live with the debt as it exists today. So I want you to consider an example before we take a look at these three approaches. Take a look at this car. We're trying to move a box, and quite frankly, we're not using the right tool for the job. So we've had to hack in a solution. We took the sunroof, we opened it up, and we dropped the box in. Now, is this a good solution? Interesting question, right? If I was to ask somebody who moves freight for a living, they would obviously say no. This is a bad solution. They know a better way to do this. But if I'm to ask my neighbor next door, he's probably like, well, it just depends. There's a shade of gray here. You know, are you moving it just down the street, or are you doing this every week? Is it raining outside? So a lot of variables that may contribute to whether or not this is a good solution. What's interesting is if we see this in code and we ask a developer, is this an okay solution? The developer immediately says no. They're like the freight guy. They know a better way. But if I was to ask the business, it might be perfectly fine. It may fit within the available risk that I'm willing to assume. So it's an interesting perspective as we think about how code kind of manifests itself, and as we talk about that code, on whether or not a solution is actually good or bad, whether the technical debt is actually good or bad. Now, let's take a look at kind of the three areas that I said that we could repay this debt if we were to try to do that. The first I would say is we could unpack the box. We can unpack the box, fit it in the car naturally, close the sunroof, and be completely fine. We've removed all of the debt. We've done a complete repayment. Pretty simple. The other thing I'd like to say about repayments, though, is that that's also a lot of effort. Unpacking the box, fitting it into the car, transporting it, and then taking it out of the car is an inconsiderable amount of effort. Same exists in our code. If we do a repayment, it is more than likely going to require a high level of effort. But if we look at debt conversion, though, remember, I just want to make it a little bit better when I'm trying to convert debt. So here, I've taken the box and I've closed the sunroof a little bit on the box, tried to secure it a little bit more. I provided some padding underneath the armrest so I'm not getting bad indentations in my armrest. Still not ideal, but I've made it a little bit better. I've made the negative impacts go away a little bit. This also happens in our code, right? We can improve it just a little bit, get a little bit of value back, but we're not suffering the full rewrite. It's better, but it's not perfect. Lastly, interest only. Just live with the debt. We just leave it alone. We're just going this one trip. It's not raining. It's just down the block. It's okay for now. I can do it this one time. I'm willing to incur that risk. That is also a very valid option in this case. So it's important to remember why we should ever pay debt. Remember, the business is not motivated by technology decisions. It's hard for us devs to come to, but it's true. You know, there's no time in the business is going to say, we need to rewrite that application because John Papa told us single-page apps are the future. That's not compelling. So it's important to understand why the business would ever be motivated to pay off any of that debt. If we don't have a good answer to this question, then quite honestly, the business is never gonna okay it. They're never going to say, yeah, we need to use now the new version of Entity Framework in this old solution. There's no business value there. So it's important to understand why we were paid debt, what business value we're going to get out of it before we engage that dialogue. Otherwise, the business will never be motivated to take action. Also, a word of warning. Watch out for this guy. Unfortunately, this guy exists a lot. He hates any code he did not write. Any code he didn't write is technical debt. Now, that's probably not necessarily true. And it's important both as development managers and business stakeholders that we look out for these types of folks because they can incur unnecessary costs where we could have been applying it to good, productive technical debt. Last section. So we've got a good idea of what technical debt is, how to identify it, how to utilize it, and how to manage it. But how should we strategically apply technical debt to our projects? Becomes a really valid question. If technical debt is in fact good, then how should we use it? I like to start by saying this. Avoid being a perfectionist in a world of finite resources. The hard truth is, and as a dev myself, this is a hard one to understand, but it's true, there's little business value in perfection. Little business value in perfection. That's hard. It's hard as a dev, but it's absolutely true. In fact, if we strive to be perfect in every single project, the higher likelihood is that we're stifling innovation. Innovation normally comes at the cost of perfection. So as we look at our dev teams and we look at the finite resources we have, we should not strive to be perfectionists. We should accept the fact that some technical debt is okay and in fact can be highly valuable. I also like to talk a little bit about some advice on refactoring. It's very common as you talk about the software development process to describe it like building a house. We say, hey, we've got to lay a good foundation because we're building a house over here. I want to caution you on this. I don't believe this is a good analogy. I don't think it's accurate, and I think in some cases it can actually be pretty dangerous. The reality is, software is nothing like building a house. If you don't believe me, just think of yourself, why do agile methodologies exist? Well, agile methodologies exist because we want to be able to accommodate change. We understand the fact that there is no predefined schema. There's no map for the developer to follow, that things may have to change as we build software. That does not occur as we build houses. If we build a house, we have an architectural blueprint. We know exactly what we're going to do. The reality is, if we think that software development's like that, then there's no variations between whether or not I have a good developer or I have a bad developer. I just need a developer that can read the blueprint. The reality is development is much more artistic than that. It's much more of a craft than that. So let me offer you an alternative view. I would say that building software is more like writing a book. Building software is more like writing a book. How do authors write books? Well, I would say that probably generally an author is going to start with an outline. They have a general idea of some structure. Now, it's not going to be a full blueprint, but they're going to have a pretty detailed outline that's going to give them some direction. And then they're going to write. They're not going to edit. They're just going to write the rough draft, right? And then once they've written their rough draft, they'll go back and they'll make changes. This is our refactoring process. And then once they're comfortable with that, they may send it over to another author, get some feedback from them. This is our code review and our peer review process. The reality is that building software is in fact completely like writing a book. If we accept that, then understanding how technical debt may come into our processes and that it's natural and okay becomes a little easier to understand. It's not a flaw in the blueprint. It's just a natural way of developers writing code. Developers are not perfect. They will make mistakes. That's okay. The problem is if we don't recognize that and we expect perfect code out the gate, we're going to have problems. We're going to have technical debt, and we're not going to have good plans to deal with it. So as we think about writing code, if we understand this process, it really helps us understand those mechanisms that need to occur in the dev team in order to produce good software, to write a good book. It could be a really impactful way to change the way we think about ourselves as developers as well. Next, I would say that we should employ strategic design. A system can't have the same high level of quality throughout the entire system. Therefore, the team can actively decide which parts of the system can accept lower quality. This is fantastic. We understand that the entire system doesn't need to be perfect, but we can allow the dev team to make strategic decisions about what is a critical function and a non-critical function, and then incur the debt on the non-critical functions to produce the software on time, on budget. Then make a plan to come back and deal with the debt. Strategic design is one of our most impactful tools as we build software. The reality is we're probably already doing it. We just haven't fully engaged the business into the strategic discussion. If we allow the business to decide, then what we get a better understanding of is when do we have a critical component and when do we not. Sometimes the development team doesn't have a clear picture of what is critical. That's interesting. So if we talk about strategic design and we phrase it in terms of technical debt that the business understands, then we can produce an overall higher quality solution that maximizes business value. Next, some advice about how we talk about debt. Now this one's going to be hard for devs, but I promise you it's important. Technical debt should always be expressed in monetary terms. We never talk about technical debt in anything other than money. The reason's simple. Remember I asked you earlier, what motivates the business? Well, the fundamental answer to any of that you may come up with is going to be money. Money is what will dictate what happens in the business. So if we're not framing technical debt in terms of money, then we're not allowing the business to fully engage. Now earlier I told you that you could use cleanup releases, buffer tasks, other backlogs to track technical debt. That is your mechanism to quantify in monetary terms the impact the technical debt is having. If I see a buffer task on a piece of code that's getting a high number of hours, then I can equate that to the amount of money that that's costing my development team. And if I can do that, then I can go to my dev managers or my project managers or my stakeholders and talk to them, how much money did this cost us this release? And then they can make a decision with me about how to proceed with that technical debt. If I'm not doing that, then the dev team just looks slow and they don't understand what's fully going on. So if we talk about technical debt in terms of money, we are allowing the business to fully engage and help us make strategic decisions. Lastly, is it good debt? I'm going to give you some 5 or 4 simple quick hits that'll let you determine if it's good debt. Is the code clean? Is the code tested? Is there a plan for payback? And is the business truly informed? If you're not saying yes to all of these, if you say no to any one of these, then the reality is you don't have good debt. Good debt is clean code, is tested, has a plan, and has fully informed the business. If I'm not doing that, then the reality is I just have a hot mess. Just like the messy kitchen before. And just in case, if you're not sure what a hot mess was, you have gone above and beyond being a mess. So that wraps up kind of the quick ideas about technical debt that I had for you. I'm going to give you a couple of quick next steps, but most importantly, if you take nothing else away from today's talk, I'd like you to take away this idea that technical debt can become a really powerful framework that you can use to talk with the business or the business to talk with the development team. But here's some other quick points. Remember, no one is perfect. Technical debt is quite honestly unavoidable. The solution is everyone's responsibility. It's not just the development team's responsibility. The business should be fully engaged in the decisions that are happening in the solution. And lastly, technical debt is a tool. It's a metaphor, it's a bridge that allows us to together make strategic decisions about our code and our solution. So I hope everyone had a great time today. If you want some more, as Mary Jo said at the beginning, I'll be doing the full version of this presentation at the VML Speaker Series on 8/20, at the Heartland Development Conference in September, and at the App Dev Trends Conference in Las Vegas. Additionally, if anybody would like to have a free consultation and we can talk a little bit more in depth about your specific scenarios, I'd be happy to give a 1 free-hour consultation and come visit you and talk through what challenges that you're seeing and put in some processes in place to maximize the benefit that you're getting out of that debt.
All right, thank you, Steve. Look for that email. We'll send you an email with directions on how to contact Steve for that consultation. And now we'll go ahead and address some questions. We had a few. Interestingly enough, they were all related to one main question, which in a nutshell, is how do you sell to business stakeholders how the time to pay off this debt?
Great question. It's actually asked, I think, every single time that I do the presentation. I'm going to give you a couple of answers to that. The first is, it shouldn't be a sell. It shouldn't be something that we have to go in and actively say, we need your full buy-in for this. The reason I say that is if we're involving the business as early as possible as a partner in the solution, and in other words, we're fully transparent about what the technical debt is, we're talking about it in terms of money, then it's not a sell. It's a strategic business decision that they're making. If they're willing to accept that it's taking $50,000 each release cycle of development time to maintain the solution because we have technical debt, then that's okay. If they're willing to accept that we can't put in new functions, features into our solution because technical debt exists, then that's a business decision. They've decided that there is not enough value in the rewrite. Now, if you feel strongly that the rewrite needs to occur, then you need to talk about it in terms of business value. Talk about the missed opportunities, and that allows them to engage. If we just say, hey, you know, Bob, that dev over there, man, he just won't follow that single responsibility principle, and that code's just becoming unwildly, and it's taking too long for us to deal with it. Nothing I said there the business will ever respond to. The business just heard you say, blah, 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 time. They heard nothing else. But if you say, hey, this is costing us X amount of dollars every release cycle, that gets some attention pretty quickly. And what you find is that it becomes an open dialogue about it rather than just a negative, hey, I need you to buy into 2 more weeks of a release cycle just so that we can fix some problems in our code. Does that make sense?
Yeah. Cool. We have one other question that just came in, and it's pretty basic. What are some other resources I can refer to?
Great question. So I've given you Ward Cunningham, who writes a blog. He tweets pretty frequently. He's a great follow. Actively involved in this discussion, especially as it continues to evolve with the modern development techniques. I highly recommend reading Martin Fowler. He has a blog dedicated to technical debt where he actively engages about qualifying how debt is good, how it's bad, and how to measure it. But also, I also promote Steve McConnell's book, Code Complete. I do this for everybody I talk to, whether you're a project manager, you're a business analyst, or you're a dev. I think that book has withstood the test of time. It's something that everybody should read and get a lot of insight about how projects actually work in the real world. So Code Complete by Steve McConnell is a fantastic resource. If you haven't read it, go out on Kindle and get it as soon as possible. So you'll worth its weight in gold. But also Martin Fowler and Ward Cunningham are the other two I'd throw out there. Bob Martin's probably a great resource as well. Bob Martin's written a couple of books about clean code that really do kind of affect how technical debt happens. And he also is an active blogger that talks a lot about clean code techniques.
Awesome, thank you. That concludes today's webinar. Thank you for attending and have a great afternoon.
Thank you, everybody.